Hello everyone, welcome back to my YouTube channel. As you can see, based on KLMN, 30 elements of electronic configuration we are going to do. As you can see, there is an atom structure, and in between there is a nucleus in the center, and nucleus consists of protons and neutrons which are positively charged, and around the nucleus there are electrons which are revolving around the nucleus, and these electrons are negatively charged. As you can say, closer to the nucleus there is K shell. These shells you can also called as energy levels. That means if you term the name shells and energy levels is one and the same. So closer to the nucleus you have K shell, and above the K shell you have L shell, and above the L shell you have M, and then you have N. If you see here, the outer shell is the N shell, which is also known as outermost shell, and less than that means before that there is one shell known as M shell, which is also named as inner shell. So now here these shells KLMN, we are going to do an electronic configuration. Before doing an electronic configuration, we need to understand that how many electrons can be filled in this each shell. That means K shell, L shell, M shell, and N shell. To know this, there are certain rules. If you see here, the first rule, that is to fill the electrons, that is the first rule is shell KLMN maximum electrons capacity obtained from 2n square. That means here the rule states that with the help of this given formula 2n square, we are going to know the number of electrons present in each shell. That is now, so in place of n, the value of K is 1. That means the first shell, that is K shell. So we put in the base of n 1 square. So here is equal to 2. That means K shell can fill maximum only 2 electrons, not more than that. In the same thing, if we have the next shell, that is L shell. So here we have the value is 2. So here 2 into 2, that means 2 square 4, 4 2s are 8. So in the same way, L shell can fill only 8, maximum 8 electrons. M shell 18. In the same way, N shell 32. These are nothing but maximum number of electrons in the each shell. Now here the second rule. Electron first filled in lowest energy level. That means this rule states that electron can be first filled in the first shell, that means which is closer to the nucleus, that is K shell. That means the first electron should be start from the K shell, then L, then M, then N. It's not like that from the last you can start, or anywhere you want to start. It cannot be from the lowest energy level. You should start filling the electron. Now here the third one, outermost shell cannot have more than 8 electron. That means here in the last shell, that is N shell, you cannot fill more than 8 electrons. That you should remember. Fourth, outermost shell can have more than 2 electrons when the number of electrons in inner shell is completely filled. That means these rule states that the outer shell, that is N shell, can only have more than 2 electrons only when the inner shell, that is M shell, can completely fill its maximum electrons in it. If it is filling complete maximum electrons in it, then only we can have 2 or more than 2 electrons in the M shell. If you are unable to understand complete rules, no problem. When we do the electronic configuration, you can easily understand. Just remember it or keep in your mind while doing. So here we start electronic configuration of 30 elements based on KLMN. Here you have first element H, hydrogen, atomic number is 1, and the base of KLMN. As we did here in the formula, by using formula, in K we can fill 2 electrons, and in L 8 and M 18, and N we can fill 32 electrons. So here the first element is hydrogen, atomic number is 1, and its electronic configuration is also 1. As you can see in the K shell, we can fill 2 electrons. So we need to start from the lowest energy level. So we cannot start from N, M, L. We need to start from the lowest energy level, that is K. Now helium, we have 2 atomic number, and its electron configuration is also 2. So as in the K shell we can fill 2, that's why we can take here 2. That is helium 2. Then next you can see lithium. You have atomic number is 3. So here in K shell we can fill two electrons. So but here we have 3. So here we fill 2, and the one remaining we fill, that is here 3. The one remaining we fill in other, that is in L shell. So as L shell has a maximum number of electrons, we filled 8. So 8 electrons can filled. So that is the reason we are taking 2 here in K shell and 1 in L shell. Lithium 2 and 1. So next is beryllium. You have 4, and here in K you have in maximum electrons 2, and more 2 is remaining. That 2 will be taking in the next shell, that is L shell. So here it will be 2. So beryllium electron configuration is 2 and 2. And boron, you have 5 atomic number. So 2 can be filled in K and remaining 3 can be filled in L. Boron 2 and 3. Carbon, you have 6 atomic number. So here we can fill 2 and here you can fill 4. Nitrogen 7, so here 2 and the remaining 5 can be filled there. Oxygen 8, so 2 and 6. Fluorine 9, so here again 2 will be here and remaining 7. So next is neon 2 and here 8. Next sodium, as you can see 11, and you have 2 in K and the remaining is 8 here in L shell, and it will be 10, but here we have 11. So the remaining one will be taken in the M shell. L has only 8 maximum electrons to be filled. So the remaining one is left over, which can be taken in the M shell. So in this way 8, 9, 10, 11. Yes, next is magnesium. Magnesium 12. So here atomic number is 12. Here we can fill 2, and here we can fill 8, and here we can take 2. In the same way aluminium is 13, and 13 means here 2, and again here in the L shell we can take 8, and the remaining will be 3 in the M shell. 14, 2, 8 and 4. 15, again 2, 8 and 5. Again 2, again 16 you have next 2, 8 and 6. In chlorine you have 2, 8 and 7. Argon you have 2, 8 and 8. Here in potassium you have 19 as an atomic number. So how you can write down potassium electronic configuration? If you see here, for potassium you have 19, so 2, 8 and 9. But this is wrong. In this way you cannot write, because electronic configuration cannot be more than 8 in the outermost shell. The rule implies outermost shell cannot have more than 8 electrons. That means here if you see you have 9, so 9 you cannot take in the outermost shell, so you need to take under 8, or 8 you can take. So this is wrong. So how can you write for the potassium? You can write down here 2, 8, again 8, and then 8, 8, 40, 16, and 16 plus 2, 17, 18. That means here 18 you got, but the atomic number is 19. So plus 1 you can add in the next N shell. So in this way 2, 8, 8, 1. So here the potassium electronic configuration is 2, 8, 8, 1. So next is calcium. Atomic number is 20. So here 2, 8, 8 and 2. So next scandium. As you can see, scandium atomic number is 21. But here again we cannot write down scandium in the same way. 2, 8, 8 and 3. But this is wrong. We cannot write 3 here. Why? Because here again the fourth rule implies, if you see the fourth rule here, outermost shell can have more than 2 electrons only when the electron in the inner shell is completely filled. That means you cannot take more than 2 electrons in the N shell. That means KLMN. If you see K shell you have 2, L shell you have M, 18 and 32. According to this rule, you cannot take in the N shell, you cannot take more than 2. Here you are getting 3, so it is wrong. You cannot take 3. Why? Because the inner shell should be filled with the complete 18 electrons. If you see in the M shell, it should be complete 18 electrons, and you are getting 8 electrons here. So how can you take 3 here in the end shell? So in this way, what you need to do, uh, 18 means, if you see here, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So in the 18, if you see 2 electrons, you can take here in the end shell, not more than 2. So the silicon electronic configuration, you cannot write in this. So you can write 2, 8, and you can write 2 in the end shell. Why? Because not more than 2. The remaining is what? How many you need to write on in M shell? If you count these 8, 9, 10, 11, 12, that means 12 you got here numbers, and the remaining the total silicon electronic configuration is 21. So 21 minus 12, if you do, the remaining will be the M shell, that is 9. So here you can write down 2, 8, 9 and 2. So here the next titanium, as you have 22 atomic number 2, 8, and here the same thing, not more than 2, and in M shell it should be completely 18 electrons filled. So what you can do, 2 you can take in N shell, and after adding this, the remaining whatever left over will be in the M shell. So 22 minus 8, 9, 10, 11, 12. So you will be getting 10 here. So this is what you can do titanium. Next you have same thing here, 8, 11 and 2. And next chromium, as your chromium atomic number is 24. So here 2, 8, and here in this you need to take 1 here in the N shell, and I'll be taking 13 in the M shell. Why 13? You need to take 12. Actually 1 left over here is adding up here. So in this way I'll take 13. So 2, 8, 13 and 1 in the chromium. This is something exceptional case. When you go in 11, 12 class, you will understand when they explain you electronic configuration. So now the chromium is 2, 8, 13 and 1. In magnesium, the atomic number is 25. So you can take here 2, 8 and here 2. Now you add these numbers 8, 9, 10, 11, 12. So 25 minus 12, you do it, you will be getting around 13. So here M in M shell you will be writing 13. So in this way the next is 2, 8, 14 and 2 in N shell. 2, 8, 15 and 2. Then again you take 2, 8, 16 and again 2. If you see here nickel, we took 2, 8, 16 and 2. Next copper, this is also an exceptional case, 2, 8, here I'll take 1. So here it should be 17, but I'll take 18. Instead of 17 I'll take 18. Here chromium and copper are two exceptional cases. They do not follow any rule. So next 30 element is the zinc element. The atomic number is 30. 2, 8. So again 2 in N, and remaining we get 18 in the M shell. So the electronic configuration of zinc is 2, 8, 18 and 2. So the 31st element, if you see, it is gallium. So gallium electronic configuration is 31. How you can write for 31? As you can take K, L, M and N shell. In K you need to have 2 electrons. In the L shell 8. In the M shell you have 18. So now fourth rule implies here, if you see complete 18 electrons are filled in the inner shell, that is M shell. So after filling 18 electrons, you can take more than 2 electrons in the N shell. So you can take 3 here. So gallium atomic number is 31. You can take 2, 8, 18 and 3. Hope you understood the complete electronic configuration of 30 elements. Subscribe and like my channel.